When performing a cost analysis between a 600 amps feeder and a 1000 amps feeder, it's important to consider several factors. Firstly, conduit size and cost per linear foot. For 1 and 1/4 inch EMT conduit, expect to pay around $1.50 to $2.50 per linear foot. For 1 and 1/2 inch EMT conduit, the cost ranges from $2.0 to $3.0 per linear foot. 2-inch EMT conduit will likely cost $2.50 to $3.50 per linear foot. When using rigid conduit, a 1 and 1/4 inch size costs about $3.0 to $4.0 per linear foot. A 1 and 1/2 inch rigid conduit has a price range of $3.50 to $4.50 per linear foot, and lastly, 2-inch rigid conduit is around $4.0 to $5.0 per linear foot. Secondly, there are additional costs to keep in mind. The wire, such as THHN, THWN2, or XHHW, varies in cost based on the size and quantity needed. Conduit fittings like elbows and couplings generally cost around $0.50 to $1.50 each. Labor costs for installation and termination will also vary based on the location and prevailing labor rates. Let's examine an example cost analysis for a 600 amps feeder versus a 1000 amps feeder, using some assumptions. We'll assume a 100 foot length of feeder, 2-inch rigid conduit, and 600 mcm THHN copper wire. For the 600 amps feeder, the conduit cost would be 100 linear feet times $4.0 per linear foot, which equals $400. The wire cost would be 100 linear feet times $6.0 per linear foot, which equals $600. Fittings, assuming 12 at $1.0 each, would cost $12. Labor is estimated at $1,000. The total estimated cost for the 600 amps feeder is $12. Now let's look at the 1000 amps feeder. The conduit cost is 100 linear feet times $4.50 per linear foot, totaling $450. The wire cost is 100 linear feet times $8.0 per linear foot, coming to $800. Fittings, assuming 12 at $1.25 each, cost $15. Labor is estimated at $1,200. The total estimated cost for the 1000 amps feeder is $2465. The cost difference between the two options is $2465 minus $2012, which equals $453. Keep in mind that these costs are approximate and may vary depending on specific materials, labor rates, and current market conditions. When performing electrical work, it's important to adhere to the National Electrical Code, or NEC. Several articles and tables within the NEC are pertinent to feeder sizing and installation. NEC Article 215 covers feeders, including the requirements for minimum size and ampacity. NEC Article 220 provides rules for calculating branch circuit, feeder, and service loads. NEC Table 310.15b16 provides ampacity ratings for insulated conductors rated up to and including 2000 volts, with various insulation types and temperature ratings. This table is crucial for selecting the appropriate conductor size based on its ampacity. NEC Article 310 also covers general requirements for conductors, including insulation types, ampacity, and installation methods. NEC Chapter 9 contains tables and examples for conductor and conduit fill calculations. NEC Article 314 addresses outlet boxes, conduit bodies, and hand-hole enclosures. It includes requirements for box fill calculations to ensure adequate space for conductors and devices. NEC Article 344 covers requirements for rigid metal conduit, or RMC, including its use, installation, and support. NEC Article 358 covers electrical metallic tubing, or EMT, including its use, installation, and support. When sizing conductors for a feeder, several factors must be considered. These include the load current, voltage drop, ambient temperature, and the number of conductors in a raceway. The conductor must have an ampacity equal to or greater than the non-continuous load plus 125% of the continuous load. Voltage drop should be limited to 3% for feeders and 5% overall for feeders and branch circuits combined to ensure proper performance of equipment. When multiple current-carrying conductors are installed in a raceway or cable, the ampacity of each conductor must be derated according to NEC Table 310.15 cone. This derating is necessary to account for the increased heat generated by multiple conductors in close proximity. The ambient temperature around the conductors can also affect their ampacity. If the ambient temperature is higher than the temperature rating of the conductor, the ampacity must be corrected using correction factors provided in NEC Table 310.15 B2R. Conduit selection depends on the environment and installation requirements. ENT is suitable for dry, indoor locations, while RNC is required for wet, corrosive, or hazardous locations, as well as for direct burial. The size of the conduit must be sufficient to accommodate the conductors, taking into account conduit fill limitations specified in NEC Chapter 9. Proper grounding and bonding are essential for electrical safety. NEC Article 250 provides detailed requirements for grounding and bonding, including the sizing of grounding and bonding conductors. A grounding electrode system must be established, consisting of a grounding electrode conductor connected to a grounding electrode, such as a ground rod, metal water pipe, or concrete encased electrode. Bonding ensures that all metallic parts of the electrical system are electrically connected, providing a low impedance path for fault current to flow back to the source. Overcurrent protection, such as circuit breakers or fuses, is required to protect conductors from overload and short circuit conditions. The overcurrent protection device must be sized according to the ampacity of the conductors being protected, as specified in NEC Article 240. Coordination of overcurrent protection devices is important to ensure that only the faulted circuit is interrupted, minimizing disruption to the rest of the electrical system. Labeling and identification of feeders and conductors are necessary for safety and maintenance purposes. Feeders must be clearly labeled to indicate their purpose and the equipment they serve. Conductors must be identified by color coding or other means to indicate their function, such as phase, neutral, or ground. Regular inspection and maintenance of feeders are essential to ensure their continued safe and reliable operation. Inspection should include checking for loose connections, damaged insulation, and signs of overheating. Maintenance should include tightening connections, replacing damaged components, and testing overcurrent protection devices. By carefully considering these factors and adhering to the NEC, you can ensure that feeders are properly sized, installed, and maintained, providing a safe and reliable electrical system.